Again, I'm Larry Mead, and Bob Ellsworth was on just a minute ago. And just get a check from Bob. You can see my screen, correct?
Sure can, Larry. Looks good.
Okay, great. So we're going to do a little introduction, kind of like, first off, why would you want to listen to us? Talk about mainframes. So Bob and I'll cover that for just a little bit, and then we will talk about the platforms that we cover, what we mean by mainframes and other kinds of things that are legacy systems. Let Bob go through that, and I'll spend a little bit of time talking about some of the um, transformation details, and Bob will also talk about some of the goals and things and options that we have. And then finally, we will get into a summary, and that should pretty much take up the time that we have allocated. So with that, I'll just jump right in and let Bob introduce himself.
Great. Thanks, Larry. And thanks for the opportunity, Ron, for allowing us to present during your webinar. And so again, my name is Bob Ellsworth. I lead the mainframe transformation initiative here at Microsoft. Been around the industry a bit, just over 50 years. Spent 30 years on IBM and compatible AMDAL mainframe, starting back in 1971, and now 20 years here at Microsoft. And started up this mainframe migration practice back in 2008. So this has been great seeing how the industry and technology has transformed over the last 50 years. Back to you, Larry.
And my name is Larry Mead. I'm a principal program manager with Azure Global Engineering, a group called Critical Infrastructure. And we like to think that, mainframes are critical infrastructure. So the kind of systems that we have in Azure that can host that kind of system is what I concentrate on. And I only have about 43 years experience, so not quite as much as Bob has. But I'll have my 26th year anniversary at Microsoft on Saturday. So, over 25 years at Microsoft, and then I spent about 17 years working on various mainframes, both from IBM and Unisys, although it was called Burroughs and Sperry back then, but also some of the what we'll call enterprise Unix systems that also there are a lot of systems that people are looking to move to cloud. So I focus on what I'll call transforming these mission critical applications into Azure. I'm sort of a application developer at heart. And I focus in on high volume transaction systems, which of course financial services systems quite often have. And they have to run on these highly available and resilient cloud architectures. And then we help with the various partners to make sure that their systems are optimized to run in Azure. So that's sort of what I work on. And with that, I'll just give you a brief overview of, if you're looking at a critical infrastructure to run Azure in, or I should say a cloud system in, I think Azure is a good place to run it because we do have worldwide coverage, and we have regions, quite a few of them in the United States, but we also have them in other parts of the world. And within our regions, we have these things called availability zones, and then we can have cross-region availability. So I guess the important thing is that not only do we have a lot of regions available, but we can have high availability within the regions that you would need for a financial services application. Plus, we can have cross-region availability and failover in case there's any kind of disaster that could happen where you need to switch over to another system in another geographic area. So, this gives the ability to not only connect to a large network like this, we have quite a bit of fiber out there to support that, but also have the ability to connect into our system through edge sites and through something we call Express Route, which is our telco type connection that you could have from your own system into Azure, because maybe you're not moving everything from the mainframe into Azure at once, and you need to have some high-speed connectivity. So that critical infrastructure is available for Azure, and it's again across regions throughout the world. This is just, I won't drain this, but this is just going through all the various things that we have that, covers the compliance that we have in various industries and also with government. This just shows that we do take compliance very, very seriously, and our systems are built around such that we can maintain that compliance moving forward. And this is sort of my last overview slide of this. Is what we want to do is have, like I say, the availability within a data center, but we also want to have the support for that hybrid cloud kind of an interface that we have, and redundancy across systems. We want to be able to run your application more or less the way you want to run it, meaning that we offer the ability to take the mainframe applications with very little change and move them into Azure, or we would have the ability to then take and sort of refactor that application to, or even re-architect it into something that could run with a sort of a born in the cloud type of services. So both of those are available, and we would run either in this highly available environment that I discussed. And of course, security is always an important piece, and we have the kind of access control and intrusion detection that you would expect from any highly available system that runs a mission critical type of services. So with that, I'm going to turn it over to Bob to talk a little bit about the platforms we cover.
Yeah, thanks, Larry. And so when you think of legacy platforms, which is what Larry and I focus on, my background's primarily IBM Z Systems, Z Series, but legacy platforms, we think about mainframes as being the IBM Z Series, running ZOS primarily, some TPF, a little bit of VM, still see some VSE and some Linux out there as well, or the Unisys ClearPath, so that combination of Burroughs and UNIVAC from the 1980s becoming Unisys, and the ClearPath side, both MCP and OS 2200. For mid-range servers and enterprise Unix, we focus on IBM Power Systems, which supports both the I series and P series, System I and System P, and also the Unix systems, whether it be Solaris or HPUX or Linux itself. And so these are the platforms that we typically engage with our customers on and help our customers find ways to transform these workloads, either through rehosting, refactoring, or re-architecting. So there's always paths that we've been able to identify to help our customers move these workloads, from their data center, from these platforms up into our cloud. Next slide.
It's not being overly responsive to me to change slides, but we'll see. There we go. Now we can go into transformation and goals, and I'll give it back to you, Bob.
Yeah. And so I don't see the slide yet, but when we think about the transformation goals, as we've engaged with customers over the last 12 years, we've seen some certain patterns and reasons, the customers' business drivers, customers are using and defining why they transform from these legacy systems to take advantage of the cloud. The first one is reducing costs. So that ability on these platforms, like IBM Z Series, it's an incredible platform. IBM has done an amazing job with it. Yeah, the slide's looking good now. But still, it's a very expensive platform compared to open systems and x86 and the cloud. And so the ability to reduce those costs is one of the biggest drivers of our customers. Skill shortage. It's getting harder and harder to find COBOL programmers, assembler programmers to take care of the system. And it's those skills are decreasingly available and also very, very expensive. So addressing a skill shortage through this transformation. The flexibility and choice, being locked into a legacy architecture, really does slow down the ability to make changes and take advantage of new technologies. And so being able to unlock that system and take advantage of cloud services as part of these legacy workloads is really a key. And then lastly, agility. Updating these systems to support the business requirements typically takes exceedingly amounts of time, fitting into a waterfall process for development. And in today's development environment, Azure or DevOps kinds of environments, being able to make incremental changes on a very quick basis, even a daily basis, is what a lot of customers are looking for. So being responsive to the business, improving time to market is one of the key drivers. And it's not one driver for any customer. Most customers have each of these drivers being important to them. Perhaps one is a little more important than others. The next slide. And so as I mentioned, our team across Microsoft has been involved in helping customers migrate from these legacy systems since 2008. And what we've done is build an ecosystem of partners that have tools and services to support these transformation journeys. Microsoft acts as a trusted advisor to ensure that you're selecting the right path, the right solution based on your particular business needs. So it's really that ecosystem of partners that allows us to transform and assist you on this and reduce the risk of these transformations. Next slide. We think of modernization of mainframe and other platforms as well. This is just an example of mainframe, but it applies across the board. There's multiple paths to modernization. We think of this as a journey, not one solution fits all. For perhaps for smaller workloads, one path may satisfy the needs. For larger workloads, you pick and choose the right solution based on the needs of those particular applications. A lot of customers go to remote hosting as the first step, especially in a mainframe transformation, moving the mainframe out of their data center, having a hoster take care of those mainframe resources instead of doing that yourself. You're always retiring applications you no longer need. In some cases, you surround the mainframe with BI or analytics. You may also surround it with APIs and other interfaces to be able to access the mainframe from other platforms. You're replacing custom apps with packaged apps. If you're able to find a packaged app that you can implement with little customization that takes over the functionality that you require, that's a good deal and a good way forward. The area we focus on a lot is replatforming, rehosting, and refactoring. And replatforming is taking the same workload and running it on an x86 environment, Linux or Windows. Rehosting is recompiling the applications to run on Windows or Linux, such as recompiling COBOL, using our partners' tools to do that. And refactoring is converting from, say, COBOL to Java or C#. And the path that you choose really depends on what your business needs are. If skill shortage is one of the biggest challenge, perhaps refactoring to Java or C#. If skill shortage is not a challenge, keeping it in COBOL is a quicker way to get off the platform. And the beauty is, once you're able to start this flywheel of migration, reducing capacity on the mainframe, reducing those costs, you can reinvest those savings and rewrite, re-architect, re-envision those applications to support your business needs. Next slide. It's really driven by those business initiatives I mentioned. So transformation details.
Okay, and I guess I'll take over from here. So if we're going to look at some of the transformation details, taking a look at specifically some things that we might be looking at for financial services. And to start off with is, we already talked a little bit about high availability, but we also want to be able to scale out and scale up, meaning that not all systems run the same way. Some systems really you want to scale out, meaning that we can add more compute resources to the system as you need to grow without really changing how it is overall spent. Or these are ones where we probably are not having share points or points where of contention in the system. And others we might want to scale up, meaning that they were probably designed as a monolith, and you would either have to completely re-architect that system if you brought it over, and you don't want to do that, then you can look at scaling them up. And if you're doing that, you might also want to do that with databases. Databases are a great example of where you might want to scale up if all of your users and systems need to hit the same database and share the data. If they can work with copies of it, then you can sort of scale out that system. But we also want to make sure that we are entering into this area where we've got the geographic disaster recovery in place. Now let's talk a little bit about something like high volume transaction systems. This could be something from payments or processing monetary transactions, or processing stock trades, or a number of different other things that can be happening with financial services systems. And one of the things that we find is that you've got this idea of having resources on demand in Azure where you can have auto scaling. That can be done with VMs, with scalable VMs, where you can scale up You can either preload them or have them scale up as needed. For instance, you could have sort of a resource limit that once it's reached, you want to deploy more VMs to then scale up to meet the load, or you can sort of preload them at a time that you know you would need them. For instance, if you have market open and stock trading, you might want to preload a bunch of compute resources such that you can meet that, and then you can have them scaled back when you're running in the middle of the day where you don't have that high volume. But it doesn't have to be just VM based. You might want to do that with PaaS services. That's platform as a service kind of systems. And we can do that in a number of ways, but two of the ways that we see that happening are with taking containerized workloads and then running those in a like a Kubernetes cluster. Within Azure, we offer a PaaS system called Azure Kubernetes Service, AKS, and that can have multiple nodes that run within a cluster, and each node could have multiple work units that are running in it too. So you can actually run a very powerful compute capability with Kubernetes within Azure, and you can also scale that across to more than one cluster of these nodes that are running. And additionally, that cluster could then be have instances that could be run across regions. So you're not only getting the scalability that you get with the scalable VMs, but you're also getting it done with a PaaS services. Some of the other things that we see is with these high volume transaction systems is we have customers that need to get out of their data centers, meaning that the business has decided that they want to close the data center, or other things that we've seen is, for instance, there's been a divestiture of a certain system within a company, or or there's been an acquisition and you need to close a data center, bring it into yours. All of these are maybe thoughts. Do you want to bring that into an on-premises data center, or is it maybe better to move that into cloud system? And that's where Azure can come in, because we have the availability in all these different types of systems. And Bob's already mentioned the idea of cost avoidance, so I won't go into that much further. But I do want to talk about unlocking some of the cloud capabilities, and I'll talk a little bit about the one that most people think of would be analytics and machine learning and artificial intelligence. Once you get the data into Azure, you can then start running all these systems that maybe weren't as easy to do on the mainframe. But I also want to talk a little bit about some of the alternatives that you might have. For instance, if you're reimagining, if you're re-architecting your system a little bit, perhaps you don't want to go from a classic scheduling product like, say, BMC Control M. You might want to instead do something like run this with an event-based system that runs your jobs. In other words, things kick off when certain events happen. That could be timed events. It could be like something showing up, which is a file from a partner. Whatever is the event that you're doing, you might want to use more of a cloud-native event process. And oh, by the way, when you're running that, you might want to burst that into something like a Spark cluster. And the way you would do that effectively on Azure is you could run something with Databricks that could then run that. So that's how some of our customers are actually reimagining not only their online during the day, but also the batch processes that they're doing, because they're then able to take advantage of cloud native features and also all the compute you can get, particularly in something like a Spark workload. I think Bob's already mentioned the fact that dev and test can be enhanced by using some of the cloud available DevOps systems. And then finally, all these can be done by picking the right pattern. So we look at rehost, really, for rehost being the one where we're keeping the code in the same language. We look at that for speed to get to the cloud. We look to refactor when sometimes we need new resources and decrease agility. And then finally, we do have some customers who say, I don't want to take this system on the mainframe and move it into Azure because it isn't working for me. It's not doing what the business needs. Under those conditions, maybe that re-architecture is the right way to go. And So, some of the scenarios, again, are high volume payment systems. We also worked at the rehosting core financial systems. This could be core banking systems. This could be everything from the DDA, demand deposit type systems, or maybe loans. We see a fair amount of that too. And also those native cloud services can be applied to any one of these as we're moving those through the process of the journey that they're taking. So I do want to talk a little bit about one of the questions that I always get from a customer is, okay, I've got my mainframe. It's measured in MSUs or MIPS, the compute power. How does that translate into something that I could, deploy in Azure? Because you've got VMs that have cores, and even your PaaS services underneath the covers are really things that are running with VMs and cores. So a few years ago, in fact, it's about 9 or 10 years ago, we actually had a test that was done at the time between Microsoft, HP, they were called HP at the time, and also Microfocus to see, okay, how do we compare MIPS on a mainframe to what we can get with cores on a x86 platform. And we found some interesting numbers that with a batch process, approximately 170 MIPS could be gotten out of a core, and with a online process using CICS, 288. So what we do is, just to be safe, we say you can probably get 150 MIPS per core. So therefore, if you're either doing this to deploy it in clusters with the Kubernetes, or you're doing it within VMs, we can then size them appropriately to give you both the power that you need, but also not over provisioning it such as you're paying for something that you're not going to ever use. So that's how we address that. Then the next thing that I'm asked for is, okay, what does an architecture look like on Azure for this? And so what we have here, it's a high level architecture, but it gives you sort of an overview of how you might deploy some things in Azure. And what this is talking about is moving a system either into where I'm refactoring it, where I'm taking and I'm refactoring it into Java, and I'm then running that in a Kubernetes cluster, or I'm perhaps using a partner emulation that's running in a VM. So if I'm doing that, I'm going to come into the system. I would then perhaps have that go into a load balancer to give me redundancy and also to spread the load across multiple resources. But as we go down the stacks, you can see each one of these has different services that it would invoke. For the case of the ISV partner with the emulation, it might be running Kix or IMS. And then for the case of something that's refactored into Java, perhaps I'm running a Tomcat server. But in either case, they eventually are going to run the programs, which then in turn access the data, in the various ways that it's done. Now I also have things off to the side here that's showing, this is something that we quite often see, is that a lot of these large batch jobs especially sort of have steps where we have sort of in-process type data or transient data, and they can be stored in things like Redis cache, or if you need to talk back and forth at the highest performance level, perhaps you can even use RDMA or remote direct memory access for being able to share information across multiple compute platforms. Now, why is that important? Well, you might be doing that today with a mainframe if you're running a parallel sysplex that's running in a coupling facilities with more than one mainframe box or KEC running that. So that's how we're able to do some of these. And then we have a choice of databases we could hook up to. You could hook up to our PaaS type databases, or you could hook up to the regular databases that are running within on VMs in Azure. Then lastly, it's sort of from this architecture, you can see that we can use Azure storage accounts. We could use something like Azure Data Factory to then get the data between storage accounts. And there's also file shares that can be run. And then the VMs could use something called Azure Site Recovery to be available across regions, in case you needed that. So I want to talk briefly about if you have some of these transformations from like some of these enterprise Unix systems. There's also cases where we can do something similar, but instead of doing it with an ISV that supports say CICS or IMS, where this particular ISV supports the Solaris type implementation. So you also have options that are similar that you could be running for enterprise Unix systems that are available. And so with that, I'm going to give it back to Bob to talk a little bit about some of the case studies we've got.
Yeah, I won't go into a lot of details, but let me just touch on these very highly, because I know we're reaching the end of our time. And of course, after this session, these slides will be made available, so you have the details in front of you. If you do have any questions, feel free to reach back to Larry or myself, and we can give you, whatever level of detail you're interested in. But just at a very high level, GEICO is a very public case study. They had a large mainframe, 27,000 MIPS, spending $100 million a year. Their goal was to reduce costs and to get off the mainframe, address a skill shortage with 1,000 COBOL programmers. They started with a fraud detection application and then moved on to the auto new business. So rewriting those applications in Visual Studio and .NET. They then proceeded to rewrite the rest of their applications. The policy management system they're deploying on a packaged app from Accenture. So this is a journey where they picked the right solution because what they had wasn't satisfying their business needs. So a rewrite and a packaged app was the best solution for them. Next slide. This is a great example of a credit card processing company that wanted to expand to other markets, to other countries, but didn't want to have to deploy a mainframe system with their processing applications running in the mainframe to those geographies. So they use Microfocus and Repro to rehost these applications using the Microfocus technologies. And that way they're able to then deploy it into new countries to support their credit card processing. And great cost savings along the way. Next slide. This is a very large workload, over 50,000 MIPS, using 100 terabytes of vSAM for doing credit card transaction inquiry service. They provide this service to banking members and credit card companies for consumers to access their credit card transactions and statements. The big challenge they had is they had rewritten a pretty simple application from COBOL into Java, but the challenge was how to get the performance they needed that they're getting on the mainframe from a 100 terabyte vSAM database. Actually, Larry worked directly on this one and implemented a solution in Cosmos DB that outperformed the solution running on the mainframe. This solution went into production in December. So great success at considerably less expense. Next slide. Then a very, very large customer, more than 300,000 MIPS that we've been working with for a couple of years now. They're selecting different paths. The first path was a rewrite of a particular application that they have. They're now leveraging cloud native services to handle the processing that occurs when the market closes, reconciling all the transactions, and then move on to the processing that's used for handling all of the stock trades during the day and opening the market when a peak period occurs. So their goal is to eliminate their data center, eliminate the mainframes within 5 years, and they're well down the path to achieving that goal. Next slide. And I know this is the close. Last thing I wanted to touch on was, why work with Microsoft and Azure? As I mentioned, the extensive experience that we have over the last 12, 13 years, driving more than 1,000 migrations, where we can help as a trusted advisor, ensuring you select the right path. It's not just myself and Larry. I'm in the Azure Apps and Infrastructure team, Larry being Azure Global Engineering. But across Microsoft, we've got resources that assist in supporting these migrations and ensuring their success. And then lastly, the technologies that have been developed deliver the levels of reliability, availability, serviceability that you've come to expect on the mainframe. In addition, provide new capabilities around elasticity, as Larry mentioned, data and analytics, modern development, and then taking advantage of new deployment solutions such as containers. So it's a way to leverage the legacy systems that you have. Don't throw away what you've got, but really continue the transformation journey. Take those systems to the new level by taking advantage of new technologies in Azure. And the last slide we'll just leave with you. When you get the deck, it gives you an example of the steps you can go through on a standard modernization journey. Again, Larry and I are fully available to support you if you have any questions, and feel free to reach out to us. Great, thank you so much.